Hello, Algebra 1 students. This is section 3.5. It is on graphing using slope-intercept form. Shout out to this lesson. I think this is one of the most important topics that you guys learn in the first half of Algebra 1. Like I said, it is called graphing using slope-intercept form, and it is the most common way that I want you guys to think about graphing. So like I said, really critical section for Algebra 1 and Algebra 2 and just your understanding of graphing. There are two things I need you to remember in order to succeed in this lesson. One of them, this is stuff that we've covered recently. The y-intercept is the point where the graph crosses the y-axis. So when we are graphing, this is our x-axis and this is our y-axis. And wherever our line crosses this axis here, that's going to be our y-intercept. The other thing that we've covered recently is that the slope means the rise over run. We like to think of slope as a fraction. So if we get a number like 3, remember to turn that into 3 over 1. Otherwise, if you had a slope like 2/3, 2 is how much it goes up and down, and 3 is how much the line goes left to right. Also keep in mind, if our slope is positive, a positive number like 3 over 1 or 2 over 3, these are both positive, the line, as you read it from left to right, should be going up. And if our slope is negative, as we read from left to right, our slope should be going down. That's a really common mistake through Algebra 1 and even Algebra 2. Let's take a little bit of time to review some things, and then we'll get into the new content. The reason I'm framing this is because I want to talk about all the different ways that we have to graph, one of which is called using a t-table. If I want you to graph using a t-table, what I'm asking you to do is I'm asking you to make a little table like this with x and y, and plug in the x values -2, -1, 0, 1, and 2. What you're supposed to do is you're supposed to plug each of these numbers in for x and see what you get out for y, and you put that number right here. So for plugging in -2, I would plug -2 in for that x, and I would have to do 3 times -2, which we know is -6, and -6 plus 6 is 0. I'm going to do this for all 5 of these points. When I plug -1 in for x, 3 times -1 is -3, and -3 plus 6 is 3. When I plug in 0, this is the easy one. Plugging in 0, 3 times 0 is just 0, so plus 6 gives me 6. I could plug in 1, 3 times 1 is 3, plus 6 is 9, and I'll do 12 lastly, and I would get, 2 lastly, and I would get 12. So, in order to graph my line, I would plot these points, -2, 0, -1, 3, 0, 6, 1, 9. It's going to be up here somewhere. We can see what this graph looks like, right? Oof, bad line. We can see what this graph looks like. It looks like that. The next way that we learned to graph was graphing using intercepts. And if I asked you to graph using intercepts, what I would want you to do is I would want you to make this little t-table. X, Y, just like over here, but now I want you to put zeros in opposite corners. When you graph using intercepts, we're often in standard form. AX plus BY equals C. You can see that we have that here. We have the X term, then the Y term, and then the constant term, or the term that doesn't have an X or a Y. Now, these are the same equations, this one here and this one. I just had to rearrange it. What I did is I just moved that 3x over. In order to move a 3x, I would subtract 3x, and I wrote that up front. So it's -3x plus y is equal to 6. This should give me the exact same equation. And it will give me the same equation. I just have to make sure I'm doing it right. And the method by which I'm doing this is now going to be graphing using, I don't know why this letter is there, graphing using intercepts. So what you do is you'd plug in 0 for x. Plugging in 0 for x makes this go away. And then we just have y equals 6. Pretty easy so far. Then I would plug in 0 for y. Plugging in 0 for y makes this go away. Now I would have to figure out what value of x makes this true. I could either just figure that out, that it's -3 times -2 is 6, or I could divide both sides by -3. Trying to get x alone, those cancel, and so x is -2. From here, I would plot both of these points, 0, 6, and -2, 0. So then I would connect them, and I'm going to get the same line. And both of these methods were pretty okay, I think. Both of these methods are not terribly difficult. I think this one maybe is a little bit more time consuming. I had to make my table a lot larger than this one here. And both of these methods should be doable for you guys. Now, this is going to be our third and final method that we are going to learn in Algebra 1 for graphing linear equations, and this is called using slope-intercept form. And there's a good chance that you guys already know what slope-intercept form is. Slope-intercept form means y equals mx plus b, and you should have heard that phrase before, y equals mx plus b. What we were saying when we say y equals mx plus b is that this form gives us some crucial information about our equation. What the b value represents is the y-intercept. Remember, we just talked about y-intercept and how that's going to be important. B is the y-intercept, which is the point where the graph crosses the y-axis. So in our problem, our m is 3 and our b is 6. So I'm going to go up to 6, I'm going to put a dot there. Look at that is one of the points from our other equation, 0, 6. We actually had 0, 6 in this table, in this table, and it's one of the points that we're using to plot this equation. So the first thing that you do is identify where the b value is. The b value is the thing that doesn't have an x with it, and it's along the y-axis. The next thing that you need to know is that the m value represents the slope. And we talked about what slope is. Slope means rise over run. So if we turn 3 into a fraction, that would be 3 over 1. What we're saying is that our graph is going to rise 3 for every 1 that it runs. So, for example, we know our graph exists here at 0, 6. From that point, we're going to rise 3, 1, 2, 3, and run 1, meaning go left to right 1, and that's going to be our new point. So these little dots that I made here are not the points, right? Basically what you're doing is you're going up 3, 1, 2, 3, and then over 1 and putting a new dot there. And I could do that multiple times. I could go up 3, 1, 2, 3, over 1. It's also worth noting that you could go down 3 and left 1, because 2 negatives make a positive. So if I go down and left, I went negative twice. And that should also be on our line. Down 3 over 1. And what we should find is that we get the same equation no matter what method that we graphed this with. So let's reiterate what we just did. Let's say it again. What we did is we looked at this and we said, hey, this is in y equals mx plus b form. The y is by itself, there's a number with x, and then there's just a number that's being added or subtracted at the end. What you do is you go to that number that's being added or subtracted at the end and you put a dot there. And then you count the slope. You turn this into a fraction if it's not, 3 over 1. So you go rise 3, run 1. Or you could, in this problem, go down 3, left 1, because going negative twice also makes it positive. So here's another example. This is already solved for. Y is by itself. So then it's in slope-intercept form, which is y equals mx plus b, right? Our b value here is -2, and our m value here is -1/2. So what you would do is you would go down to -2 on the y-axis. Remember, b is the y-intercept. So you would go down to -2 on the y-axis and put a dot there. And then from this point, you are going to rise -1. Rising -1 would be going down 1, right? rising positive number would be going up, and rising and negative number would be going down. So you are going to rise -1 and run 2. Don't go negative twice. Remember, going negative twice actually makes our line go up, makes it positive. Going down 1 and right 2, now our line, as we read it from left to right, is going down. And because we have a negative slope, we want our line to be going down. So I can keep rising -1 and running 2. I could also rise a +1 and run a -2. As long as I'm going negative once and positive once, that's going to be going downward, which is what we want because our slope is negative. So I can connect these, and that's my line, that's my equation. Here's one more. This one is a little bit of a trick. It doesn't have anything that's being added or subtracted at the end. So the b value here is actually just going to be 0, and the m value is still going to be -2/3. So here's my y-axis. There's nothing being added, so the b value is 0, so the y-intercept is at 0. And then from this point at 0, I would rise -2, which would be go down 2, and then run 3. 1, 2, 3. Put a dot there. Notice that this line is going downward as we go from left to right. It's going down, and my slope is negative. That's the number one thing that people screw up. I will say the two things that people screw up are not having a negative slope when it's not having it go down when it has a negative slope. And I do see a lot of people, so the y-intercept is -2, that's where you start. Some people will put it there on the x-axis. They get that switched. So those are the two things that I see screwed up a lot for these equations. I could go down 2 and over 3 again. Remember, if I want to go negative, I could also go up 2, but then left 3. That'll still make my line negative. And there's my equation. There's my line. The last one that I want to talk about here is an equation where it doesn't start out in slope-intercept form like this one. This is not currently looking like y equals mx plus b. So this is actually in standard form. I could make that little t-table with zeros in the corners and go from there. But instead, this is a lesson on slope-intercept form. Let's look at how we would graph it using slope-intercept form. We want the y by itself, and there's currently a positive 2x over there. So in order to move a 2x, I'm just going to subtract this 2x on both sides. Because those will cancel, y is equal to, I actually want to write, because it's in y, we're looking for y equals mx plus b. I want the x term to go first, and the x term is here, and it's negative, so it'll be -2x. And this 3 is positive, so it'll be plus 3. Now I can identify my y-intercept. My y-intercept is 3. My slope is -2, which we like to call -2/1, right? Because we like to think of slope as a fraction. So from here, we would rise -2 and run 1. Rise -2 and run 1. So go down 2 over 1. We could also remember go up 2 and left 1. That'll still be on our line. We see that our slope is negative. Our line, as we go from left to right, is going down. So I'm fairly confident that this is right. And I have successfully graphed this using slope-intercept form. Please be sure to reach out to me with any questions. Thank you.